Good afternoon, students. Welcome to the lab class of computer graphics. Today's lab will be seeing graphics transformations. Okay, before doing that, as we know, everyone are taking these lectures online, and I think most of you are not having the graphic library. So let me first explain you how you can download and set your libraries. Okay, to do that, I have shared this with you on Blackboard. Okay, so you can go on Blackboard. Okay, in our course in computer graphics lab, go in content, and you have here glut libraries. Okay, follow this link and you can download from here. Okay, so download this. You are going to get this folder for you. Okay, it will be in RAR. Just unrar that and you'll get this folder. Okay, once you open this folder, we are having two things here. One is developer C++. Here you are having developer C++.exe file, and other you are having here glut libraries here. Okay, so first is you need to install developer C++. Most of you might be having the already developer C++, but these specific libraries are going to support only this developer C++ what I am having here. So please uninstall if you have any other version. Okay, let me uninstall what I am having it on my computer. I already have dev C++, so let me uninstall this. So I'll just go in control panel. Okay, I'm going in control panel, uninstall a program. So here I have this dev C++. I'm going to uninstall this. Uninstall. Just wait for a couple of minutes, it will be very fast. Do you want to? Yes, close, done. So it is uninstalled. Now let us go to our folder. Okay. And here let me close the other folders here. So we'll install this. So once you open this folder, you'll find developer C++ and glut libraries. Developer C++, we are going to install this. Okay, I agree. So here, remove old configurations. Next. Now we are installing it. Okay, this will support only 5.2.0.1. okay, if you have this one, then it is okay, no need to install. But still it doesn't support that, then uninstall and install the one what I am providing you. Yes. Okay, run, finish. Okay, now it is ready for me. Developer C++ is ready. Now the next step is I want to add these libraries. So open this folder and we'll open one more folder. Okay, so I open C. So this is the folder where I have my glut libraries, and this is C on my computer. So first thing is I want to copy the include. So here I'll go in program files x86. On some of the systems you will find this in Arabic. Okay, so just follow that where you have the x86. Open that, go in dev cpp and go inside min-gw32. Okay, so now you have include here and include here. Go inside include and you have GL here. Okay, open GL, and here as well go inside include and open the GL. Okay, so here from our libraries folder we'll copy this, copy all, controls, and paste it here in your local disk C in min-gw32 include GL. Okay, so you are going to paste it. Yeah, do this for all current items. Continue. Okay, so now include content is done. Next we'll copy the libraries. So we'll go in lib. We have some libraries here. Here as well we are going to go in dev C++ in min-gw32. We have lib. Okay, so we'll take this 4 libraries and we are going to paste here, Control V. Okay, so I have the libraries here now. So this is done. So there is one more thing we have to do, is glut32.dll. okay, in this min-gw32. Once you open this one, you are having, so include the GL files we have copied. Next in lib we copied all the libraries, and here we have glut32.dll. copy this glut32.dll and go in C. Okay, and you can see Windows. Okay, C Windows. Now search for sysvor64 and paste here in sysvor64. okay, right now I have already, so I'll replace the file in the destination. Continue, just copy here in sysvor64. in this folder you need to copy this. Okay, so with this we have copied all the libraries. Okay, and make sure there is one more thing you have to remember. In this program files x86, when you open dev C++, this is min-gw32. okay, we need this folder. This is very important because everything include and libraries are here. Now depending on your operating system, there will be one more folder created here on some computers, depending on your operating system you're using. So here with min-gw32 there will be min-gw64. there are 2 folders may be created. If it happens so, then delete the folders min-gw64. okay, if you get here one extra folder min-gw64, then delete the folder min-gw64 because we need only min-gw32. if you kept this min-gw64 like that and you didn't delete that, then you are going to get the error when you are running your program. Okay, so this we have set up. Now we'll start a project and we'll add the libraries from there and we'll run and see the software is working or not. Okay, this is done. So I have one sample code here. Let us run that. Okay, so I'm just copying this sample code, Control see. Let's open up project, file, new project. We have console application, project name. Okay, today we are going to do basic transformations. So let's say transformations. Okay, and here this we are going to store in, so on the desktop. Usually you can store in anyway. So on the desktop, I have one folder for the programs. Okay, CG Lab programs. Okay, computer graphics lab programs. So you store anywhere on your computer, on desktop or anywhere, but make sure you remember the path where you are storing it, because when you are running, when you are executing, the main file should be in same folder where you are storing this file. Okay, so save. Okay, now we have the code here. Now copy this code, so we have to run this. Now before this, we'll just add the libraries for this project. So go in project, we have project options, go to parameters, add library or objects, and here we'll go in C, this PC, C program files 86. Now we have here developer C++, MinGW32, and here we have lib library. So here, from here, we are going to add 3 libraries: lib OpenGL32.a, open, and add libraries lib GLU32.a, okay, and lib GLUT32.a, open. So you can check here. So make sure you got all these 3 libraries you have included: lib OpenGL32.a, lib GLU32.a, and lib GLUT32.a. Say okay. So now the setup is ready. Let us see this sample code it is working on. So now make sure when you are when we are running this, so we have to save this file main.cpp. okay, it should be saved in the same place where I have created this project. So I created this project on desktop and CG Lab programs. Okay, so main file need to be stored in the same place where I have stored my project. Save. Okay, now this is a simple window which is created by this code, and we are having this one here. Okay, as we already seen till now in our lab, we have seen how to create a window, then we have seen how to create the objects. Like we have done a lot of things with lines, triangles, quads, polygons, and line strips, quad strips, triangle strips. Okay, now in today's class we'll see the transformations. So let us take a basic figure, and then we are going to do transformations on that. Now so here right now, okay, okay, we have our x and y axis. It's not at all good. Okay, so this is my x, this is y, and in a program okay, so in a program we are having on the x-axis from 0 to 600, on the y-axis we have 0 to 500. Now let's suppose we have here 0 to 600, and 0 to 500. Okay, let us make a small triangle which is lying here. Okay, we'll make a triangle, then we'll apply the transformations on this. Okay, so GL begin GL triangles, and let us have the color for this one. GL color 3F, and red, let me give the red color red. I'm keeping 1. Green, I don't need green. Blue, I don't need the blue. Then GL end, and here we need to make a triangle we need 3 vertex, so GL vertex 2I, need vertex 1, vertex 2, and vertex 3. So by the figure we drawn here, we can take first as something around 50 and 50, and here 150 and 50, and let us take here something around 100 and 150. So here I'll take 50 on x-axis and 50 on y-axis, and 150 on x-axis and 50 on y-axis, and here we'll have on x 100 and on y 150. Okay, now if I run this, I got a triangle here where I have A, B, C. The vertex are 50, 50, 150, 50, and 150. Now let us apply the translate here. The translate is for moving the object. Now this triangle I want to move. Okay, so in this class we'll see all the 3 transformations: translate, all basic transformations, translate, rotate, and scale. Okay, so we'll start with the translate. So translate, let us understand how this is going to work here. So as we know, these points are 50 and 50, and this point is, this vertex is on x 150 and on y still 50. and here the third vertex is on X, we have 100, and on Y we have 150. Okay, now when we apply translate, so right now this we are doing in 2-dimensional, so it will be applied on X and Y axis. Now whatever translation factors will be giving Tx and Ty, as this we have already seen in our theory. So Tx and Ty will be added to all the, so Tx will be added in each vertex on the X. So here the value of X, it will be added. Like for example, if you want to move on the x-axis to some 200 points, and on the y-axis to 200 units, okay, 200 units on x-axis and 200 units on y-axis. So 200 will be added, so first on Tx 200 will be added to everyone, on Y as well, if whatever we'll give, that will be added here. So here let us use the function for translate. So for that we are going to use the function here, GL translate F. Okay, the function for translation is for movement is GL translate F, and here this function need to be passed with 3 parameters. Okay, so these parameters will represent 3 axes, X, Y and Z. So it will represent the translation distances on X-axis, on Y-axis, on Z-axis. So this is representing from the theory the Tx, Ty and Tz. Now we are doing in 2D, so we don't need the third one, but still this function need to be invoked with 3 parameters. So we can't do it with 2 parameters if you are not using 3D. Okay, that will be an error. So right now we are not doing anything on the third axis, that is Z axis. So distance there will keep at 0, so that means 0 movement on the Z axis. Okay, so on the X and Y axis, for example, on X axis I want to move some 200 units, and on Y axis maybe again 200 or any number, whatever you want to move. Okay, on X axis 200, on Y axis 150. That means it will add 200 to everything, like this 50, 150 and 100 will be added by 200, and this 50, 50 and 150 will be added by 150. Okay, so 50 plus 150 and this 50 plus 150 and this one. Now if I run this need to be moved to 200 units on X axis and 150 units on Y axis. Oh, just a minute, we missed something. Okay, the matrix mode, so need to be initialized before initializing the glue ortho 2D. Okay, now it will work. Execute, compile. Okay, now it is working. So here earlier this figure was here, now we apply the transformations, the translation. So we are translating on the x-axis to 200 units, and on the y-axis it has translated to 150 units. Okay, it's up to our requirement, we can keep the translate values anywhere on minus and plus as well. Okay, so we have done with the translate. Let us move to the next, so now scale this. So execute, compile and run. Okay, this is our original triangle. Let us scale. I want to make this double of this size. Okay, this is whatever size it is, the original size, I want to make it double. Okay, to make it double we are to change the size. So basically to change the size we are going to use the scale function. Okay, so this scale we can use to make this size shrinkable, that is to make this size smaller or to make this size larger. So if you give the values less than 1, the size will be smaller, and if you give this scaling factor more than 1, the size will be become larger, and if you give the scaling factor as 1, the size is going to be remain the same. So here we'll have the function gl scale f, and here again we need to give 3 parameters for x, y and z. Now as we know, on translate we are adding this, and in scale we are multiplying these factors to these things. Okay, so when we are multiplying, we are going to keep here on z1, because when you multiply anything by 1 it remains the same, because as we are not doing anything on the z-axis, that's the reason we are keeping on the scale this one as 1. Okay, next gl scale f, so we have to give sx, sy and sz here. So sz we make 1 so that it doesn't make any difference on the z-axis. Now sx and sy, so sx, as we want to make the double size, so we'll make 2 on the x-axis and 2 on the y-axis. Okay, so it will make double on the x and y-axis. So here 2 will be multiplied to all the things on the x-axis, and 2 will be multiplied to all the units here on the y-axis. Now if we do this, that will be double the size. So if we are running this one, okay, so this one has doubled its shape. Okay, the original shape has doubled it. Now you can apply this with the various things. One is, if you want, you can make it smaller, 0.2 and 0.2. So if I execute with 0.2 and 0.2, it has become very smaller. Okay, and if we are making it, so differential scalings, like on x I am giving, make it 3 times, and on y make it 2 times. That means this is a differential scaling we are giving. So on the x-axis, the terms on x-axis will be multiplied by 3, and the terms on the y-axis are going to multiply it by 2. So with this we are going to get the figure like this one. So on the x it has multiplied 3 times, on the y it has multiplied only 2 times. Now one more thing here, that is okay, so one more thing here, we made this triangle over here. This was the place we made this triangle, but when we are scaling it, it is changing its position as well. Okay, now even when we make it small, from here it moved somewhere here. Okay, so whenever we apply the scaling, it is going to move to some other place. Okay, if you want to do the scaling at the same place, we can apply fixed point scaling. Okay, fixed point scaling, which we have seen in theory, where we have seen that will be done in 3 steps. First is, like, we will select a fixed point. Okay, we will find the fixed point. Like usually we select center of any object as the fixed point, and we'll move this center to the origin. Okay, we'll move this center to the origin. Now if you take this pixel, the translation the fixed point, this fixed point is nothing but, I'm writing here, this fixed point is how much on x. On x, so it between 50 and 150, so on x maybe it is 100, and on y so it is between 50 and here it is 150. So we take on y as well, we can take 100, on x 100, on y 100. So we can take this point as 100 on the x and 100 on the y, because we take this as 50, this as 150. So maybe like in between we may have the 100 on the y-axis as well. So taking this one, so as we have seen the general two-dimensional fixed point scaling in theory, that we multiply three matrices. That is, first the matrix 1, matrix 2 and matrix 3. Okay, in matrix 1 we do translate with the fixed point xf and yf. Okay, then we applied the scale, then we have done translate with minus xf and minus yf. So now we'll apply for this translate with xf and yf, then scale, then again translate with minus xf and minus yf. Okay, so let us do this thing now. So here, for example, I want to make the double the size, and we have seen these three steps: first translate, then scale, then translate. And translate with xf yf, what we have decided as 100 and 100, and then we'll do the scale, then we'll do the translate again, and translate f with so yeah, as we have decided, so we'll do translate. Okay, translate with 100 and with 100 and 100, and then scale. So scale, I'm making double the size. Last is translate f, that is we'll do translate again with minus 100 and minus 100. Okay, that means what we are doing here is we are taking this object at this fixed point is coming on the center. So we are having this object here, and here it's going to change the size, that scale will be done. Next we are moving back to the same position with the minus 100 and minus 100. Now we'll say here minus 100 and minus 100. Now, so if you do this, execute, compile and run. Now, so the fixed point was here. At the same point, this object is changed its size. It has become bigger but stayed at the same position. It doesn't move away when we are increasing the size of an object. Okay, so now when you apply this now for making it smaller as well, it's going to be stay at the same position. So earlier we have seen it is going near to the origin. When we are making it, we are making it smaller. Now if you make it smaller, again it will stay at the same position. The position is not going to be changed. Okay, so we have done translate and scale. Now let us do the rotation. Okay. For rotate, we are going to use the function gl rotate f. Okay, so and here there is little bit difference. The parameters here, parameter difference is we are going to have here 4 parameters. Okay, first will be angle, and next we need to decide the axis. Is it x-axis rotation, y-axis rotation, or z-axis rotation? Okay, this all 3 axis rotations will be different. Now angle, that is, for example, I am giving angle as this figure now. First, okay, this is our original figure. I want to rotate this angle to 180 degrees, for example, so it will be totally flipped. So I need the angle as 180 degrees. Next, so we have to decide how it is going to be rotated on x-axis, how it's going to be rotated on y-axis, and how it is going to be rotated on z-axis. Okay, see, for this I'll just show you one. Okay, you can see here on y-axis the rotation will be along this side. Okay, it will be rotated along y-axis if you select the y-axis. On z-axis the rotation will be like this. Okay, and on the x-axis on the x-axis the rotation will be like this, and on the z-axis the rotation will be like this, in this way. Okay, now that means for our screen on the xy plane the rotation will be on the z-axis. Okay, that will be on z-axis. Okay, so here for our figure we are going to select no on x-axis, no on y-axis, and yes on z-axis. Okay, so rotation we are going to have 0 on x, 0 on y, and 1 on z-axis. If I run this now, see, there is one problem. When we are rotating it, this object, when we are rotating, okay, this object when we are rotating it here, as we have the window from 0 to 600 and 0 to 500, it is rotating and changing its position, and it is moving somewhere around here. Okay, it is moving, rotating and moving somewhere else around outside of our window. Okay, to get it back to the original place, to stay at same place and do the rotation, we need to apply rotation at pivot point. Okay, so that we can do again in the same way. Here, as we have fixed point we have taken here for scaling, we'll take the same point as pivot point for rotation. Okay, so on that point, so this one will be moved to here and rotation will be done and it will get it back here. So here, in place of scaling, we are going to have just rotation matrix, and we'll have the translate with 100 and 100 and translate with -100 and -100, and in middle we are going to have rotate. So let us apply that and see. It should come back to the same position and need to apply the rotation. So here we are going to apply a translate before this, GL translate F, and we have translation factors as 100, 100 and 0, and we have one more, GL translate F, and translation factors -100, -100 and 0. Okay. Now if you run this one again, so we have done the translation. Earlier it was like this, so 180 degrees, so it is completely flipped and come back to the same position. Okay, so this is the rotation on z-axis. Okay, now you can just check how it will be if you are doing the rotation on x and y axis. Now you can make rotation with respect to y-axis. Okay, as we discussed earlier, on y-axis the rotation will be like this. Okay, so it will be flipping like this one. Okay, so now the rotation will become, okay, so it is moving 180 degrees, so that means making the same. So let us change some angle to it. Let's have 60 degrees. So now, okay, so you can see only just some part of that one. The same way, if we are rotating this on the x-axis, it will again smoothed around the x-axis, so we can just see only this part. Okay, so maybe with some other angle we can see some more part, so you can just play around with these angles. Like just moving to the 15 degrees, so we can see some more of this figure. Okay, so it's just 15 degrees it has been rotated. But to make it clear view, for us the XY plane will be better, so you can just have XY plane. Okay, you will get one more view. Better will be Z axis. Okay, so if you do the Z axis with 15 degrees, so now it has rotated 15 degrees. On Z axis it will, we can see the complete figure on our screens. Z axis rotations. Okay, so we'll continue the rotations in next class, the transformations in next class. Again we are going to see some more continuous transformations in next class. Okay, till then the task for you is install this and complete your lab assignment and submit that as soon as possible. I think you have we are already late to submit your lab assignment. Okay, just make it as soon as possible, and you can leave any messages on your WhatsApp group or here if you have any questions. Thank you, students.